We view the elite human athlete as a masterpiece of biological engineering, but the sheer physical effort required to perform at this level is immense, a constant struggle against the limits of our own anatomy. No matter how much we train, we eventually hit a biological wall. Our muscles fill with lactic acid, and we fall into a deep oxygen debt that forces the body to slow down or fail. Our internal complexity is a burden. Massive organs and intricate systems require constant, exhaustive maintenance, creating points of vulnerability that need to be managed just to keep us in the race. Then there is the grasshopper. It's a common garden pest with a mechanical design that makes human biology look heavy and outdated. It doesn't just jump, it launches with a level of efficiency we struggle to replicate. This comparison raises a difficult question. Is it possible that our complex design is actually a limitation? To find out, we have to look at whether physical supremacy is rarely found in simplicity. The difference begins with how we fuel our movement. While humans rely on a massive centralized cardiovascular system, an insect operates with a much leaner internal map. The human bottleneck shows that we rely on one central pump to push oxygen-heavy fluid through miles of restricted tubes to reach our muscles. It's an energy-intensive process that limits how long we can perform. The grasshopper decentralizes this entire process through spiracles. These tiny openings deliver oxygen directly to individual cells. It's a direct-to-consumer delivery system that bypasses the need for a heavy centralized heart. This efficiency extends to their kinetic limits. If a human tried to jump 20 times their body length, the force of the muscle contraction alone would shatter our bones. The grasshopper circumvents this through a material called resilin. It's an ultra-elastic biological substance that can store and release more energy than almost any other material on the planet. Instead of relying on brute muscle strength, the insect slowly cocks its leg to store potential energy in the resilin. When it releases that tension, all that energy is dumped into a single launch. Physics do the work that our muscles can't. By replacing heavy pumps and explosive muscle contractions with decentralized supply and pure elasticity, the grasshopper breaks through the physical barriers that keep human athletes grounded. Our vulnerability is also a matter of structure. With a soft exterior and an internal skeleton, humans are dependent on external gear shoes, pads, and clothing to protect ourselves from the environment. This internal design leads to a recurring cycle of injuries. Joint friction, ACL tears, and slip disc are the natural results of a skeleton that must support all our weight from the inside out. The grasshopper carries its support on the outside. This exoskeleton functions as a built-in support system, acting as a structural barrier that distributes the force of an impact across the entire body. This external frame serves as a biological shock absorber. It manages the stresses of high-impact movement without the need for the constant maintenance or internal lubrication that our joints require. We spend millions on carbon fiber prosthetics to try and match this level of durability and energy return, yet the grasshopper grows this high-performance structure naturally. By moving the skeleton to the outside, it is designed to be a self-sustaining machine that avoids many of the structural failures, like ligament tears, that plague human athletes. We build more complex gyms, develop more complex medicines, and follow more complex routines, believing that complexity is the key to better health. But every layer of complexity is a new point of failure. Our intricate systems are what make us susceptible to ailments like high blood pressure and chronic physiological stress problems that don't exist in simpler designs. The grasshopper operates with a specialized frictionless efficiency. It was designed to function at its physical peak until its life cycle is complete, bypassing the systemic breakdowns we face. While humans spend decades trying to get fit through effort, the grasshopper is chemically fit by design. We don't need to look for a breakthrough in a lab or a high-tech gym. The most efficient athlete on the planet is already here. We're building a community of like-minded individuals who love nature and healthy living. Click like and subscribe. It's free and it only takes a second, and by supporting us helps us to create more content like this for you. Thanks for watching, and don't forget to turn notifications on.